here. So we don't want the camera, so this is a class node. So now we're gonna do define an element. So go over here, or click over here, Femap. Hopefully we have it. 11.3. Okay, so hopefully I'm recording this. All right, and I will be able to post it and I will give you a link, but otherwise, pay attention. So let's see. I'll take this one. Let us create the geometry. So let's say over here, I'm going to take point E as the origin. Okay? So we take point E as the origin. So let's say we have geometry points. So this point will be E. Then we're going to create point F will be, what will be point F? At 250, no? Okay, let's do it together. So if I go ahead, stop me. Next, what will be point G? 500. Okay. And point H will be at 1050. Now we're going to create the ones all the way to the top. So if we start from point D, that one will be located at what? At 750 and a height of 300. Now we start going back, so this will be what? 500 for point C. 250 for point B. And 0 for point A. Okay? Now we need to go and create point J and K. So this one will be located where? At X equal 500. What will be the Y? 100 for point J. And 750 and 100 for point K. Okay, and you click cancel. Now if you want to center this, you can just go and click Ctrl A. All right, and now I don't know what is best to do. Well, I'm going to try one way. If it doesn't work, we have to change it, but I'm not going to create lines, I'm just going to create the surfaces. So surfaces, geometry, surfaces, corners. So that would be, what would be the surfaces modeling? The panels or the webs, no? Yeah? So we come over here, we don't want this. You can go here, method, click on methods, on point, and let's create this one first. So you click this one, enter, next point, enter, next point, enter, next point, enter. We do the same thing, select, enter. Here be careful, it needs to go all the way down, not the panel. Alright, you look for the second panel, this one, and this one. So we have two panels. Now this one will have two different panels, no? One for the top, one for Q1, one for Q2. So this is the one for Q1. This is the one for Q2. And you click cancel. Okay, now guys, what I was going to do initially, let's do it, okay? We might have to be careful at the time of meshing, but at least for the modeling will be good. So these surfaces will be modeling the webs or the panels, all right? Now, what do we have around the webs and the panels? We have stiffeners, okay? In order to model the stiffeners, we're going to use some type of element, but let's just do lines now for the stiffeners. So let's say tools. We don't really need them, but let's just do it for the sake of understanding. So project points, I guess. So the first one would be from where? From point A, enter to point D. So that would be the top flange. Okay. Then we have the bottom one from point E to point H. Now we have from point B to point F, from point C to point G. Oops, what did I do here? Okay, from point D to point H, and then the one in the middle from point J to point K. Okay, we didn't need them, but it doesn't matter. Cancel. All right, so over here in the problem, in this problem when we solve it, did we mention anytime the material of what this structure was made? No, okay? So over here, however, for final element, you need to give the material. So you can go to material, right click, new. And really, it doesn't matter which material we use, but let's say we use aluminum. What is the Young's modulus for aluminum generally? That is between 70 and 75 gigapascals, so it doesn't matter what we use. Let's use 70. What is the Poisson ratio? That one you should know. For every metal, what is the order of the Poisson ratio? 0.3. Okay, what is the physical meaning of the Poisson ratio? I'm not asking you the thing to test you, no, but just to reinforce previous knowledge, I hope. What is the physical meaning of Poisson ratio?
It's the reduction in cross-sectional area due to swing.
Correct. So for example, if you have a structure which is this way, if you're going to stretch it, if you stretch it, what's going to happen? It's going to become thinner, no? So it's the relation between the stretch and how much it comes out. Perfect. So we do this. You can put a title if you want, for the sake. Then cancel. So if you go here, you will see your property has been created. Now we need to go here, properties. You right click and you click new. So you go to the right hand corner, you select material. So what do you want to model first? You want to model first the panels or the stiffeners and flangers? Okay, so we go to stiffener and flangers, you click element property type, and here you have a lot of elements. So we say that the assumption that is made is that each one of the members only carry loads in the axial direction. Okay? This is why it's called one force member. So do beam carry forces in just one axial direction? No, beam can stretch, but also they can do what? Bend, no? Okay? So what is the option over here is to use a rod, and this would be the line elements. Line elements means it is modeled by a line. Plane elements means if they are modeled by a surface, okay? And solid, forget about it for now, okay? Volume, solid is modeled by volume. So we have rod elements. You click OK, and you need to put some properties. Do we know the area of the stiffeners? We don't know, so over here it doesn't matter. Generally I put 1 so that the value of the stress, if I put the area equal 1, the value of the stress will be equal to the value of the force, no? What is stress? Force over area, no? So if I put A equal to 1, the stress will be equal to the area, but you don't have to put, you can put whatever you want. In some problems, you might actually have the correct area for each one of the members, no? But not in this case. So, okay. So cancel, so we have the property over here. So now we need to be careful here. So mesh control, size along curve. I think here you can just, you see, you have one long curve and then you have one for each surface. Let's try to do it this way, see if it doesn't create a problem. Select all. Okay. And then instead of putting number of elements, go to element size And I think that if we use an element size of 50 millimeters should be enough. Okay, so now you should see little points showing up, no? You click cancel. What I just did? Mesh, mesh control, size and on curve, select all, okay? You click to element size, you put 50. I mean, if I redo it, I hope it's not going to do anything bad. And you click OK. All right, and then cancel. Let me see one thing here. If you go here to geometry, yeah, I'm probably going to have to do this one. Let's see. Huh. Just to make sure here, go to geometry and uncheck all the surfaces, so we only have these lines. Okay, we only have the roads. So now you go to mesh, geometry. What type of geometry we have? Curves. And here, let's select one by one, okay, top, bottom, this one, this one, this one, and this one. And we click OK. You have road property, you click OK. Okay, over here nothing looks different, but actually if you pay attention, little green points you have created on each point. I don't like this option here, but why is this icon so small over here? I don't even see them. I think if you click that little one over here, view style, and then you go to thickness cross section, you see kind of put the rows with the cross section. But again, this time it's so thin that we can leave it if you want. So we did this, we did the structure. Now we need to mesh what? The panels, no? So here we are. So now we go, hopefully we have the size, mesh. Let's redo it just in case. Let's try if it doesn't do it. Geometry. Oh, we need to create the property first, sorry. So we have the properties, you go to the left again. We have the property for the roads. Now we need to create a property for the panel. So properties, new. Okay, we model the shear panels with what? With a surface, no? So that is what type of element? Is that a line element or a plane element? Okay, so which one we need to choose over here, you think? Shear panel. Okay, and this one, again, you can apply the thickness. In our case, we don't know it, so I'll put 1 millimeter, okay? We have everything in millimeters. And then this one is kind of tricky. I had to go, to tell you the truth, they change it all the time. But I had to go to this to find out what was the meaning of those F1 and F2, all right? And I will give you a copy of that page, or I will put it in the class notes. Basically, I find out that if you make these values pretty small, so I do 0.0001, 0.0001, and I leave the other one 0, it works good. So you click OK. Now you should have the property over here created. You should have it on your left tree. So click on that one, double click on that one, so it's active. Go to mesh, and now this is the part not 100% sure, but to geometry, surface, and select all 4 surfaces, and hopefully the size will be in there, and click OK. And now if it's not selected because you didn't click, make sure you select the shear property, and you click OK. Did you use 50 or did you use another one? Did you use the same size or different size? I think it's the same, no? Yeah, it looks about the same. Let's see. Yeah. Okay. So let me check something here. I'll go to the tree, properties, elements, by type, so I have 53, you can move the tree a little bit to the right, and 90. That looks like a lot. What would be 90? All right. Let's try it this way. So now you need to go to Tools, check, because we have two different meshes, the nodes of each element might coincide. So let's check this one, check, then you click Coincident Nodes, Tools, check, Coincident Nodes, you click Select All, okay, and now you can say here, okay, and it says 57 nodes were merged. If you want, you could preview. Let me just redo this. I do Control Z. All right. So Tools, check, coincident nodes, select all. Okay, you could do preview. So you see all those nodes were coincident. All right, because of the two meshes, and you say done, and okay, and you should say the same thing again here. 57 nodes merge. All right. So let's try to save this file. Save as. I think finally I have access to my shared drive. Just today they removed me. Here we go. So A418. So when was the last time I taught this class? I created that one yesterday, summer 2014, you see. So lectures, yeah, I put the lectures notes over. Oh, I didn't put it. It did not let me save it. But I will put over here. Let me put over here new folder. So let's say this is our Nastran 1. That way if you need the file, if we need it. So I just call it this one, whatever, model. Or just say, whatever. What is this one? Example 1? Example 1. You save it, just in case we don't need to restart from 0. So now the next thing we need to do is to apply the loads. Okay, now if you go here, you see you can unselect the shear panels and so on, so they will be there. 1, 2, okay. I'm looking at this point. This is 1, 2 up. Okay. All right. So now we need to apply the load. So model, load. I'm going to apply the loads on the nodes. Okay. So nodal. You can put a title over here. Call it loads, whatever you want. I don't put anything. And let's say this is, where do we have the?
At 100.
At 100. So this is 300 is 1/3, no? So we go over here, and now I'm going to need your help. So the force when we calculate a node is 4,000 at an angle of 60. So on the y direction, I know 4,000 cosine 60 is 2,000. And then I think you give me the value. I mean, I can go and look at the value, but 4,000 sine 60 was 3,400.
Yeah, 64.
64 point what?
1.
No, but give me everything.
Oh, 101 615.
615. Because otherwise, it might not give you exactly 4,000. Okay? You click OK, and it should tell you exactly 4,000. If you run that off, maybe it's not going to give you exactly 4,000.
Okay.
Okay? So did you get this? Now we can go to the other one, which how far was it? So this is, each one is 50, it will be 100, 200, 250, no? Yep. 1, 2, 3, 4, 5. What load do we have over there?
5,000.
Minus 5,000. You click cancel now. Let me remove this. If we put, yeah, we put it at the right place, and this one, same thing. Okay. So now what do we need to do? We need to create the boundary conditions. So model, constraint, nodal. You can put here fixed boundary condition, whatever you want. I don't think it will make any difference, but You want to just fix the top and the bottom, or you want to fix all of these ones? Top and bottom? I don't think it will make any difference, but let's try this way. We can try. It can affect the panel, but
I think from those points.
it will still make it deform. It doesn't matter. This point will still. Let's try this way, okay? And then you can try the other way. I don't think it will change anything, or very little. Okay? So now, what would be the boundary condition for this one? This should be fixed. So basically, no moments and nothing like that. So okay. So you have 1, 2, 3, 4, 5, 6. Cancel. That's something I like to do, but it's not mandatory. You go to File, Rebuild. Yes. Basically, it just means that if you did too many times, undo, 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 you're just gonna clean the code, no? All right. So basically, now you can click on that little 2 gears over there, Analyze Model. This will take you over here, or let's do it through the tree if you want. You can right-click. You can either do it from here or the tree. Let's do it here. Right-click on Analysis, Manage, New. We're gonna run a static problem. In this case, always gonna be static, but you have different solutions. Okay, all different type of solution. This is for vibrations. This is for transient frequencies, so on and so on. For static. So basically it means static. What is the main equation this is using? So measure of force is equal to 0. Epsilon equal to sigma equal to E epsilon. Okay? And you can click over here, Analyze. And hopefully we should not have any error or anything. So it says good. Click over here. To close that. Now you go to results. All results, they are there. Okay, double click. Okay, so now you don't have to do this, but maybe clean up this a little bit, remove all the surfaces. Now, this is something I like to do. You don't have to do it again. Right click on Shear panel, put color, and put any color you want. I'm going to use that ugly green over there. All right, you click OK. And you change the color. I know. So this is a new version. Mine will not do it, but this one did it. Okay, so now we cannot see the forces. We cannot see anything. So where are the forces? Why did they disappear? All right. So anyway, let's now press on F5. See what happened. Why I don't see forces? Hold on one second. I'm going to check something. Are the forces there? Loads. Yeah. Yeah. Okay. So F5. Click first criteria. It's going to give you values. And now click deform. Control data. So you want to put here for total translation. It's probably very small. And what the first thing we calculated was what? The shear flows. So let's try to check the shear flows. You see all the stuff that it can give you here. Here I see shears, span 0.1, 4, 5, blah blah. Shear panel max stress, shear panel average stress. So let's just select 6019. Shear panel max stress should give you the same as the average. You click this one, and you click OK, and again OK, and hopefully we got the same values. Are they about the same? This one are changing a lot. I don't know why. So maybe we need to clamp it. What did we get for Q1? So it's pretty close now. What did we get for Q2? 2.56, about the same order. What did we get for Q3? That one was 0.67 something, no? And this one now, that one is changing a lot. What did we get for this one? 23. So it's that the order is over there, but some of them are going high.
That maybe have to do with only picking 2 points.
Maybe. So, all right. So let's do and try to redo the problem. See if we change the bounding condition, we get something more uniform over here, no? But anyway, basically you see that the order looks okay, no? The order of the values. So let's go back. We don't have to go back really, but it's going to become more complicated. All right, let's delete this one. Right click and say delete. If we need to rerun it, rerun it. You could save everything, but then I think you might get confused. So this one, preserve, undo. So let's save. So now we can just go here, for example, to model, loads, body, constraints over here. Constraint definition on node. So right click over here, and we can just go here and say where applied. So we apply here and the top, but where else can we apply it?
The rest of the points.
The rest of those points, but it doesn't let me select them now.
I guess you
What happened here?
Oh, I think, wouldn't it be, instead of where applied, it'd be the other one, like edit constraint?
Reapply. Well, I don't see why I don't have first the nodes over here. Let me. Did everything disappear because I removed the surface? Let's see. Yeah, everything disappeared because I put these things at those points. So leave this. So reactivate those geometry, and let's go down. I mean, we can create a new one. It's not a big deal, but constraint. So right click. Where apply? I think it's where apply, no? Where apply, and now let us select this one. So select. We have 117. Select this one, this one, this one, this one, and this one. You click OK. So now we should have all this line over here. And go to File, Rebuild, and yes. Okay, now you don't have to recreate everything. Just go like the little gear on top over here. Analyze model. You click on it, and you should do it. Close this. F5. Deform contour data. Okay. Okay. Okay, it is better. A lot better, no? So I guess you were right. We have to constrain all of them, no? So now I think these values are kind of similar to what we got for Q1, Q2, Q3, and Q4. All right? So now, let's do, now what do we need to check? What we did on those panels. So if you want here, go to shear panels. You don't have to, but I will remove this. Yeah, remove this for now. And we keep the rod elements. So we go to F5 again. Deform contour data. And now what do we need to select? So probably I will select, I mean, this rod axial forces, this is really what we want, but could we select the rod axial stresses? Yes, because we put the area to be 1, but the real one will be rod axial forces. Okay. Okay. So now, oops. F8 SY top is to recenter everything. If you want to move this up and down, just click on Control, and then the middle bottom in the mouse, and you can drag it down. Then zoom is to move by the little wheel. Okay, so what was our value at point A was 10,325, no? Here, what do we get? 9,652.5. Any idea why there is that difference over there? Because when we create the mesh, this value over here is basically the average value between the value at the point over here at the wall and the point at this node over here, no? Yeah? So you don't have the nodal value over here. Does that make sense? So it would be a little bit smaller. Instead of having values, it's also put in red colors. You could have, you go to F5, so control, I recentered this, F5, you could just say here bin diagram, and you see for each element it will give you the diagram. So we did this one for the flange ABCD. You see the way it is now? We did one for the other flange here, no? You see it goes a little bit on top. All right, then we can do maybe this one or this one. If you want, I can show you a trick. I mean, it's not a trick, but if you want to look at the data a little bit better, you can go here to groups. So double click on groups, right click, new, and let's say let's call this one flange A, B, C, D, okay? You click OK, and now you go to group. So let's say we're going to take the elements ID, and here you can do one by one. Let's see, we'll do one by one. There are not that many, or you have different options, but let's say you select these ones over here. All right, so you click OK. After selecting all the top ones, OK. Now you re-go to group, you have your group over here. You can right click on it and say show active group. And it will just give you that one. Yeah? Okay? You could do the same thing for the lower one, no? So now you can go to groups, show full model, do on your own the bottom one, okay? You can go to groups, new groups. What was that flange over here? Flange EFGH. EFGH. Okay? And you can do the same thing. Group, elements. You can do ID over here, ID. But then, for example, you can go method a little bit faster. You can say on curve, and you can select the curve. I will just do that once. And OK. You go to groups, show active group. I will just show you for this one, okay? And you can check the values. For example, what was the value we had over here? Minus 6,000. I think was going about 600 in. So this was compression, this was tension, no? Yeah? So probably we're not going to have time today, but let's prepare the final element. Next time we're just going to do one other stiffer. Which one do you want to do next time? This one, the last one, or the middle one? The middle one? The last one? I don't care. This one here, up and down? Okay, so let's select now the group. So let's do the group, new, and then we do it in class. That will be, what will be the letters for that one? DKH, no? So stiffener, DKH. And okay. So go to group, elements, ID, you can select the curve or whatever you want. Method on curves, probably faster. Okay. I'll go to the stiffener, right click, show active group. Okay, so that one looks a little bit strange. Control A to center. Next time we try to derive the distribution of this one. Okay, so let's just write it down. So save this model. And let's just write that next time we need to do what? Stiffener DKH. So we have time to do the plot, but let me stop the recording then.